Okay, let's look on to part 2 of our voting unit. So, something we didn't mention is, with these style of voting, we could have a tie. And let's talk a little bit about tiebreakers, if we have two people that are winners. So here are some real life examples of when we've actually had a tie. In the Academy Awards in 1932 and 1969, there's a tie for Best Actor and Actress. When there is a tie, both of them won the Oscar. In the Grammys, there have been several ties. In 2019, there's a four-way tie for the Best Rap Performance. Not a real question for the notes, but do you know who those four people are? For the NFL MVP in 2004, Manning and McNair tied, and they shared the award. The Cy Young Award in baseball, there's only also been one tie. So in these big awards that we might probably have heard of before, it's possible to have a tie. In some of these cases, you can just share them. If it's just an award, that's fine. You can both have the award. But sometimes that wouldn't make sense. I probably couldn't have two presidents. That wouldn't be a really good tie. Something like that. So in this case, we have tiebreakers. So some actual examples in real life of ties. In the Virginia House of Delegates, there's a tie for a seat. So to pick the winner, they drew a name out of a hat, which sounds crazy for a real election, but at a tie, it could come down to something as simple as chance. In Arizona, there is a tie for city council, and they pick cards out of a deck. Whoever had the higher card won. So those are two ways that ties have been broken. So now I want you to think of what are some other ways. If we have an election and there's a tie, what could we do? With the condition that both people can't be winners. So try and think of one or two ways that we could break a tie. Okay, now let's go back to this math club election. So the most common method we use for election is what's called the plurality method. So simplest and most commonly used, which I'm guessing that some people probably did when we picked the winner last time of our math club election. And in this method, all that matters is the amount of first place votes a candidate receives. So take a second and think, what type of ballot should we use if we only care about first place? So think back to the types of ballots I showed last time. Which one could we use? Maybe tell me why. Why should we use that one? Okay. And then looking at our math club example, if you go back to those ballots and count them all up, A had 14 votes, B had 4 votes, C had 11 votes, and D had 8 votes. So if we just count the first place votes, A wins. Right? Let's look at another example. So the fabulous TSU band goes bowling. Tasmania has an amazing marching band, and we're invited to go to 5 different bowls to play. They must vote if they want to perform at the Rose Bowl, Hula Bowl, Fiesta Bowl, Orange Bowl, or Sugar Bowl. So on this table, we have a chart. In the left-hand column, we have on our top row, we have number of voters. So 49 voters voted this way, 48 voters voted one way, and 3 voters voted this way of first, second, third, fourth, and fifth. Okay. So I want you to try this. Pause it, then I'll go ahead and give the answer in a second. But who wins if we are just counting first place ballots? And our answer should be first place. That's all we're counting. We're using the plurality method. We can make an assumption that R stands for Rose Bowl. And they had the most first place votes. They had 49. But now that gives us a question. The Hula Bowl had 48 people who wanted to go. So is this fair? Those 3 people that voted for the Fiesta Bowl, maybe they'd rather go to the Hula Bowl. So sometimes the plurality method isn't the best method. Oftentimes when it's really close and we're just picking a winner, plurality might not be the most fair. Or it could be. It's all up for interpretation, and every scenario is always going to be different, but it's something to think about. So I want you to discuss these things, or discuss meaning answer in your notes. So we said who the winner was, but now I want you to think of a better method to determine a winner. What bowl should the team go to make the most people happy? And what is the problem with the plurality method? So answer these 4 questions in your notes. I gave you the answer to the first one, that the Rose Bowl would win, but what's a better method we could use? And then start looking at the second, third, and fourth, and fifth place to see if there's a better option. So my hint for the last part is really focus on what people said here. Look at this row. See what's going on here. But again, there's no right or wrong answers. It's all up for interpretation. So give these a try. So now I'm going to give you a new type of voting method, and it's called the board account method. So this is probably the second most common used method. In this method, last place is worth 1 point, second to last place is worth 2 points, first place is worth n points, meaning n is the number of candidates. So in my example below, if we have 4 candidates, if you haven't noticed, this is the math club election. There's 4 candidates. So a fourth place vote would be worth 1 point. A third place vote would be worth 2 points. A second is 3. And a first place is 4. So whoever has the most points would win. And remember, who won under the plurality method? Let's think. Do we have a new winner here? So pause it and give this a try. Who wins the math club election? So we look at A. They have 14 votes for 14 votes. Each first place vote is worth 4. 14 times 4 is 56. Let's look at second place votes. They don't have any. Third place votes. They don't have any. All the rest of their votes are last. So people either love person A or think should be in last. So if we add those together, we'd have plus 10, plus 8, plus 4, plus 1. So what is that? 679, I believe. 66, 79, yeah. So A would have 79 points. Try that for B and C now. And D. How many votes would each of them have? We'd have 32 for B, 42, 30. So just look at all the B's and add them together. 16 and 2. Add those all together. C is 40, 4, 24, 28, 8. No one voted last place for them. And then D is 32, 12, 3, 20, and 14. So add those all up together. Just like I did for A. Add all those numbers and see who the winner is now. So you can pause it, do those calculations. We're adding everything. Let me make sure we know we're adding. Everything's being added. And B would win. Boris would have the most points. So if we add up all of Boris's points, you can see just by adding the top ones, it's a lot more. I'll let you add up C and D, but since this is the winner, 32 and 42 is 74, plus 30 is 104, plus 16 is 120, plus 2 is 122. So B wins by a lot here. But you can count the other ones up. I don't think any of them should go over 100 or come close, but not 122. All right, so Boris is your winner. So we already see, depending on what voting method we use, we could have a different winner. Plurality A wins, Borda count B wins. Okay, so here we have a little understanding check. This is an assignment that you can find on Canvas. Go ahead and answer those questions. Just make sure you fully understand everything. So take a break from this video, go to Canvas, do the understanding check. All you have to do, answer on a piece of paper, take a picture and upload it, and that will be your understanding check. Or you can even just type it in on the box in Canvas. I'm not really picky on what method you want to answer, like the form of how you answer them, but I want you to answer these two questions. All right. So now let's look at the Heisman winner. So this is still the Borda count, but it's a modified Borda count. So like we said before, if we have 1,000, let's say, just to make it easy, people, we don't want 1,000th place to be worth 1 point, and then first to be 1,000. That would be very unnecessary math. Instead, we just say first, second, and third. Those are the only votes. People were using a truncated ballot, so we say first, second, or third. And we give those point value assignments. So first is 3 points, 2 is 2 points, third is 1 point. So we're using the Borda count. In 2019, I believe this is, 2019, Joe Burrow had 841 first place points. Or 841 first place votes. And those are all worth 3. He had 41 second place votes, which are worth 2. And he had 3 third place votes, which are worth 3. You add those all up together, he'd have 2,608. So he has a lot more points than anyone else. So, in this scenario, he'd actually win using the plurality method too, but that might not always be the case. If someone had a lot of second place votes and someone else had first and third place votes, it's possible that all those second place votes could be enough. But this is a modified version of the Borda count. So we can do this as well if there is a lot of candidates, so it still does work. Okay, method number 3, plurality with elimination. So this is still the plurality method. So we are taking the winner, but we're going to eliminate the lowest. So count the votes as if you're running a plurality election. If a candidate has a majority of first place votes, they are the winner. If not, eliminate with the fewest first place votes and redistribute those votes. All right, so let's say that again. We count the votes as if you're running a plurality election. If a candidate has a majority of the votes, they win. So don't have to do anything. But we're going to focus on this next part. If not, we're going to eliminate the person with the fewest first place votes. Then we're going to add those votes to whoever they voted for second. We're going to recount the votes. If a new candidate now has the majority, they are the winner. Otherwise, we repeat this step, and we just continue until we get a winner. So let's look at an example here with the math club. So here, in first place, so number of votes, 14, 10, 8, 4, and 1. So here we need to add actually all the number of voters together, because we don't know how many people voted. I believe it should be, I don't remember. Let's add them together. 14, 10, 8, 4, and 1. So 24, 32, we had 37 people vote. Okay. So to get the majority, you would need 19 first place votes. Because half of it, if we had 16 votes, sorry, if we had, 37 divided by 2, let's think of it that way. 37 divided by 2 is 18 and a half. Can't have 18 and a half votes, so you would need 19 votes. So we'd say 19 votes wins. Okay. So we're going to look who has the least amount of first place votes. All right? So who has the least amount of first place votes looking at our chart? C does. C only has 1. Nope, sorry, they have 11. 1 and 10. B has the least amount of first place votes. Okay? So let's write it this way to keep track. A has 14. We'll just write it in order. B had 4. C had 11. And D had 8. So we eliminated B. Now we're going to move those votes to their next preference. So if B can't be the winner because they didn't have that many votes, this is the lowest number. That's 4. We're going to redistribute those 4 votes. So if B can't win, they would rather have D win. So their second choice of those votes are D. So we're going to add 4 to D. So all those B votes, we're going to now go to D. Okay. Now we keep going. 14, 11, and 12. No one has the majority. But our new smallest number is now 11. We have 14, 11, and 12. So we do it again. C is eliminated. So let's look at this row first. 10 people pick C to win. Their next choice would be B, but B is eliminated. So those 10 votes would go to D. So they would have 22 points. But we also had one person go this way, so which actually is also going C and then D, so +1. So they would have 23 votes. And even if we didn't count that person, 22 is already the majority. So now D would be the winner. So this is plurality with elimination. You eliminate the person with the least amount of first place votes, and you redistribute their votes. In this case, B had 4, that's the least amount of first place votes, but then they'd prefer D if B wasn't the winner. Okay. Then we still didn't have a majority, so C only had 11 first place votes, so we eliminate C. Those 11 people would prefer D over A, so those 11 votes are going to all go to D. D then has 23 points. They are the majority. Yeah. So now D is the winner. Right. So I'm going to give you one to try now. So it's not going to be a group activity, but it's an activity. So this is what I want you to do in your notes. So if we have this mayor election, you need 151 votes to win. I want you to tell me who the winner is. So I'll do the first step to kind of help you out. And then I'm gonna have you finish and tell me who the winner is. So we have A. We're gonna count their first place votes, which is 93. B has 44. C has 10 and 30, which make 40. We'll write D and E on this side. D has 42. E has 81. Okay. So which one of those numbers is the smallest? 40 is the smallest. That'd be C. So we eliminated those. And now we redistribute their second place choices. So these 10 people, if C doesn't win, they would want A. So we add 10 to A. So A would have 103. These 30 people, so that was this. These 30 people then would rather have E. So we add 30. So we'd have 1, 1, 1. So you're going to keep continuing this process until someone has 151 votes. Okay? So I'm going to let you finish this one, but let's look at these numbers. D has 42. That's the now lowest number. So now work down this column. Redistribute those votes. Remember, C also has been eliminated. So those votes would go to E. But try and finish it from here. Who is the winner? Okay. So here is our last method to pick a winner. So this method is called a pairwise comparison. So a useful feature of a preference vote is it allows us to find a pairwise comparison. So given any two candidates, X and Y, we count how many people voted for X over Y and Y over X. We give 1 point to the winner, 0 to the loser, and 1/2 if it's a tie. So in our math club, we see who likes A better than B, who likes A better than C, who likes A better than D. We look at B compared to C and D, C compared to D, and we award all of those points. Okay. So this is how we'd calculate this. So if we look at A versus B, so we pretend C and D aren't there. We have A versus B. A had 14 votes, B had 23 votes. Okay. Meaning, on the ballots, 14 people voted A over B. So if we remember, if we go back to that slide if you would like, if A is 14 votes, those were all 14 first place votes. Those B 23 votes were actually every other ballot. Every other ballot had B voted above A. So even if you voted B for third place and A for last place, those people still prefer B over A. So in the pairwise comparison, people prefer B over A. Okay? And since we know, again, A only got first and last place votes. So A versus C, same thing. A had 14 first place votes, but 23 people voted C above A. So C would get a point. So let's keep a tally. We have A, B, C, and D. B got 1, C got 1. Okay. If we look at A versus D, again, same thing. A got first place votes, but everyone else liked D better than A. So D would get a point. So that doesn't really give us any information other than people either like A or don't like A. So how it's going to be broken up is how B, C, and D compare against each other. Because A didn't get any points, so A's actually get 0. So they didn't get any. So look at the other comparisons. How do people like B versus C? This one's actually really close. On the ballots, 18 people put C over B. C, 19 people liked better. B, 18 people liked better. So we'd add a point to C. We have 2. Okay. If we compare B and D, B would also beat D. So we'd have 2 points. And then C versus D, C again is our winner. So C would have 3. So using the preference ballot, C is the winner. Okay. And this is what this is what it tells us. There's 4 methods we just talked about. In every single method, we had a different winner. So that raises the question, what's the correct method? Should we use the plurality method? Should we use the board account method? Should we use plurality with elimination? Should we use pairwise comparisons? Because depending on which one you use, each person could be president. It just depends on what method you're using. So that raises the question, which one should we use? And there isn't a right answer. You could make an argument for every single one of these, and you would be correct. It's all opinion. That's why everything has its own rules. Because in voting theory, there's no correct way to pick a winner. It's you pick a method, and then your method determines a winner. So we will talk a little bit more about fairness. But we can now see, so what I want you to take away is depending on the method you choose, you're going to have a different winner. All right. So let's talk a little bit more about that. So we have what's called fairness criteria and Arrow's impossibility theorem. So we have different criteria for fairness. So the first one, known as the majority criterion, is if there's a majority candidate, they should be the winner. If there's a clear majority, that person should win, because then everyone would be happiest. So if you have 100 people, if 60 people voted first place for that person, that's the most fair. That person should be the winner. But we saw in the math club example that there wasn't a majority with A. Since there wasn't a majority with A, then there was no clear winner. So then all the 4 different methods would give us a different winner. So a majority meaning more than 50%, or even sometimes people say 60 or pick different numbers, but majority, we're going to just simply say here more than 50%. If you have more than 50% happy, that seems fair. Okay. Our next piece of criteria is if there is a candidate who beats each other candidate in a pairwise comparison, then the candidate should be the winner. So let's say in A won all of those comparisons, if it was A versus B, A versus C, and A versus D. This didn't happen, but let's say in all 3 of those, A wins. So if you prefer A over all the other candidates, it should be over. A should be the winner. Okay. So in a pairwise comparison, if you beat everyone, you should win. Should be over. Okay. The next one, monotonicity. If candidate X is the winner of an election, then X should still be the winner had a voter ranked X higher in their preference ballot. So this one means if, let's say, candidate A had a bunch of 4th place votes, if you moved all those votes up to 3rd place or 2nd place votes, that should still be the winner. So this one kind of, almost to say it worded trickily, but kind of obvious. If you give someone more points, if you think of it that way, they should still win if they're the winner. Okay? And then the independence of irrelevant alternatives. So if candidate X is the winner of an election, then X would still be the winner, has one or more of the irrelevant alternatives not been in the race. Okay. So this is actually one that sometimes plays a big part in real life elections. If you have a candidate that has no shot of winning, you can even think politics here, sometimes they stay in the race to pull votes from the top candidate. But if we're just talking about strict fairness, no context, the fair way to do things is the candidate that wins should win, even if that person that got maybe 5% of the vote wasn't there. So it's just something to think about. Doesn't mean that is a rule. It's a criteria. It's a theory. It's how can we make things fair? Doesn't mean that every set of rules is fair. Okay. However, this is called the impossibility theorem because if there are more than 3 candidates, you cannot satisfy all 4 of the following criteria. Unless, rare exception, there is a clear first place favorite. If there's not a clear first place favorite, it's impossible to satisfy all 4 of these. So in a small scale, you could do a little election and sure, there might be a majority and all 4 of these happens. But in practice, in real life, it would be impossible. You can't satisfy all 4 of these things. So the word impossible, I'm using loosely. It technically is possible if everyone voted the same exact way, first, second, third, and fourth on the ballot. Sure, that all 4 of these things could happen. But think to yourself, what's the likelihood that every single person, even in a classroom, would vote the same way first, second, third, and fourth? So it's impossible, most likely. Let's think of it that way. Okay. So now you have all the information needed for Project 1. All the directions for Project 1 can be found on Canvas. I wrote it right there. So please read through those directions. If you have any questions on that first project, please send me an email. I'd rather you send me an email and have a great understanding of the project instead of just trying to do it and have some confusion. So always feel free to send me an email. I can help out with that. So remember, for each unit, there should be some understanding checks. You should be turning in your notes for these videos. In those notes of the videos, you should be answering the questions that I've asked. There's going to be a project and there's going to be a homework. That homework is on MyLabs. After watching these 2 videos for this unit, you should be able to do all of those questions. Again, on those, if you have any questions with the homework, just send me an email. I'm always happy to help. But that is going to wrap up our first unit. Please pay attention to those due dates. And again, any questions, just shoot me an email. Have a great day, everyone.